Welcome to Midnight Thoughts, a place for simple questions about things we see every day but rarely stop to question. Fingerprints are everywhere. They unlock phones, they open laptops, they appear in crime shows every night. Just lines on skin. Simple, nothing special. But here is the strange part. Not a single fingerprint has ever repeated. Not once. Not even between identical twins. Same DNA, same parents, same womb. Yet the fingerprints are different every single time. That feels wrong. DNA is supposed to copy everything. Eyes, hair, face shape. So why does it fail here? Imagine lining up millions of people. Everyone presses a finger onto a glass surface. The screen fills with patterns. No two are the same, not even close. This is not luck. This is not coincidence. This is biology doing something quietly strange. Fingerprints start forming before birth, very early, before names, before faces, before memory exists at all. Around the 10th week of pregnancy, something unusual happens. The skin on the fingertips begins growing faster than the tissue underneath it. There's a problem, not enough space. So the skin does what skin always does when crowded. It folds. Those folds slowly become ridges. At first, they are smooth, almost boring. Then reality gets involved. The fetus moves, hands touch the womb, fingers bend, they press against soft surfaces. Nothing dramatic, just normal movement. But at this scale, small things matter. Even the flow of amniotic fluid plays a role. Tiny currents, tiny pressure changes, microscopic differences begin to appear. A ridge bends slightly left, another splits, another stops early. These differences grow, they reinforce themselves, and then they lock. This process happens once, only once. There is no reset button, no second draft. Identical twins share the same DNA, but they do not share the same exact physical experience inside the womb. One twin might move a hand earlier. One finger might press slightly harder. One moment of pressure changes a ridge forever. That's all it takes. Think of it like crumpling paper. Take two identical sheets, same size, same material, crumple them at the same time. They will never look the same. DNA provides the plan, but fingerprints are shaped by controlled chaos. Genes decide the big picture, the general pattern: whorl, loop, arch. These are the three main fingerprint types. Most people fit into one of them. But the fine details are not written in the genes. Small breaks, tiny splits, sharp endings, sudden turns. These details are called minutiae. They are what fingerprint scanners actually look for. Even if two fingerprints look similar from far away, the minutiae never line up. That is why fingerprints work so well for identification. Faces change, beards grow, voices age, fingerprints stay. You can cut your finger, skin heals, the pattern returns, unless the damage goes very deep. Burns or scars that reach the lower skin layers can permanently change a fingerprint. That is rare. For most people, fingerprints last a lifetime, from birth to old age, unchanged. There is a common myth that fingerprints are completely random. They are not. They follow rules. They follow physical constraints. They form patterns shared by all humans. What is random is the fine detail. Another myth says identical twins have identical fingerprints. They do not. They may look similar at a glance, enough to confuse someone casually looking, but under analysis, the differences are obvious. Law enforcement learned this long ago. Early fingerprint databases showed the same result: millions of prints, no duplicates. Even with modern computers scanning massive databases, no two full fingerprints have ever matched perfectly. Now comes another quiet question. Why does the body even have fingerprints? They are not decoration. Fingerprints improve grip. The ridges increase friction. They help fingers hold objects without slipping. They also increase sensitivity. The ridges amplify tiny vibrations. This helps the brain detect texture. Without fingerprints, picking up small objects becomes harder. Coins, paper, smooth surfaces. So fingerprints are functional. The uniqueness is a side effect. Nature was not trying to create an identification system. It was solving a physical problem. The uniqueness came for free. Now imagine explaining this to someone 200 years ago, that invisible forces before birth shape permanent patterns on the skin: pressure, movement, fluid. No microscopes, no DNA, no computers. Yet today, these invisible patterns unlock phones, open doors, and identify people across the planet. There is one more quiet detail. Even fingers on the same hand do not match. Each finger develops independently. Different angles, different pressure, different timing. 10 fingers, 10 unique maps. To match 2 fingerprints perfectly, every ridge would need to form the same way at the same moment under the same pressure in the same environment. That has never happened, and statistically, it likely never will. Fingerprints are a quiet record of a moment before birth, a frozen snapshot of movement and pressure. They look simple, just lines on skin, but they carry a complex history that never repeats. So, if fingerprints never match, even in twins, what other things in the body look identical at first glance, but hide differences shaped by moments no one ever sees? If you have a thought or a different idea, you can leave it in the comments. If you enjoy these questions, you can like the video and subscribe for more. Midnight Thoughts.